Lateralog deep. Actually, Lateralog is one of the types of the electrical logging tool, and it was designed to increase the quality of the apparent resistivity method. The main idea is like that. Once we are looking at the apparent resistivity tool, in case of the heavy resistant rocks, the electrical current do not penetrate through, so we cannot get the detailed information about its resistivity. Another problem is once you get one tiny layer with a really high resistivity. Just like the same story, electrical current do not penetrate into it. In this case, we are not getting the exact information about the resistivity of this layer. To avoid that problems, a special tool was designed, and it's called the focused log or the Lateralog. Lateralog is a special tool designed to prevent the current leakage. How it works? If we are looking at the simplest tool of Lateralog deep, it consists of 3 electrodes: A1, A0 and A2. These 3 electrodes push the electrical current into the outer space. And it occurs that the current from the central electrode is pushed to move only inside the formation. And that's how we can prevent the current leakage. If we are looking at the dual Lateralog, it can be divided onto Lateralog deep or LLD and a Lateralog shallow or LLS. Lateralog deep tool is designed to push the current to go deep into the formation. And that's how we can obtain the information about the resistivity of the rock far away from the tool. That is giving us the really big investigation depth of the tool. In contrary, Lateralog shallow force the electrical current to go into the formation, but not as deep. And in this case, we are obtaining the information about the electrical resistivity on the shallow part of the formation. That is giving us 2 different logging curves, Lateralog shallow and the Lateralog deep. On this slide, we can see then an example of the Lateralog deep or LLD. Here we can see this curve shown in black. And as you can see, the general shape of the LLD almost similar to the general shape of the apparent resistivity that is shown here in black. That happens because both of these logs are showing actually the same property, just it is measured by a bit different ways. The main objectives is the thin layer detection, determination of the rock electrical resistance, determination of oil and gas saturation, and the correlation of the cross sections. And the limitations of this well log. These are, it's applicable only in not cased well, and it's not applicable in non-conductive drilling mud. Induction log is a special tool designed to measure the electromagnetic waves. In this method, we are forcing the electromagnetic wave from the induction coil into the formation. These electromagnetic waves interact with the rocks, and the rocks in turn pushes the secondary electromagnetic wave that can be measured on the receiver coil. In the end of the day, the signal that we receive is proportional to the formation conductivity. So conductivity is a property of the rock that showed us the possibility for the electrical current to flow through this rock. So it looks like electrical resistivity. In the end of the day, the logging curve of induction log or ILD, induction log deep, shown here in blue, shows the reading that is opposite to the reading of the electrical resistivity, like LLD, which is shown here. In certain cases, induction log curve can be recalculated into the scale of resistivity. And in this case, LLD and ILD gonna show the same readings. The main objective of the ILD log is determination of apparent conductivity, detection of the boundaries, and identification of oil-saturated zones, and the correlation of the cross sections. The limitations are it's not applicable in steel casing. The interesting story is that we can use the ILD in case of the plastic casing. In certain examples in the world, we can see that the bottom part of the well is cased with a plastic casing. And in this situation, we can use the ILD to control the resistivity of the rock. And by controlling the resistivity of the rock, we can control the oil saturation of the rock. Another interesting thing is that induction log can be done even in non-conductive fluids. For example, if we are using the petroleum-based drilling mud, we cannot use apparent resistivity and the lateral log, but we can use induction log. Another problem of the ILD is that it got the low resolution in high resistivity sections. So in case of the high resistant rock, ILD gonna show you a bit incorrect readings.